A carbonated bottle once needed a complicated stopper until a corrugated metal disc made sealing fast, cheap, and deliberately temporary. In a Baltimore bottling room in the early 1890s, the expensive part was not the liquid. It was persuading a restless, carbonated drink to stay inside cheap glass while wagons rattled over rough streets. Corks could seal bottles, but they varied, required handling, and often needed wire or other restraint. Reusable stoppers added pieces that had to be cleaned and returned. The small object that changed this work was a shallow disc of metal with a wrinkled edge and a compressible lining, William Painter's crown closure. Painter did not invent the idea of closing a bottle. His achievement was to make the closure cheap, dependable, quick to apply, and disposable. United States Patent 468,226, granted on the 2nd of February, 1892, describes a metal cap whose flange is bent into locking engagement beneath an annular shoulder on the bottle head. A packing disc sits under compression against the lip. The geometry turns downward pressure and crimping into a tight joint. The companion patent 468,258 makes the economic idea unusually explicit. Painter described a cap effective enough to seal a bottle yet inexpensive enough to throw away after a single use. That sentence belongs to a new industrial world. Instead of preserving the stopper as a miniature piece of equipment, the bottler could treat it as packaging. The consumer removed it, and the next bottle received a new one. The edge mattered. A flat disc alone could not grip the neck. Painter's skirt was corrugated into a repeated crown-like form. When a crowning tool pressed it down, those flutes bent around the glass shoulder. The lining supplied resilience and filled microscopic irregularities at the mouth. Metal provided strength, the softer disc provided conformity. Neither material did the whole job. This demanded a matching bottle finish. Standard closures become powerful only when the object receiving them agrees on the interface. A cap could be made by one supplier and a bottle by another, yet they had to meet at the same diameter, shoulder, lip, and compression. The unnoticed achievement was therefore not merely a better lid. It was a repeatable relationship between glass, lining, steel, and machine. Speed transformed the economics. A closure that could be fed from a hopper, placed over a mouth, and crimped in a single press suited mechanized bottling. It reduced the ceremony of stopping each bottle. The cap arrived as a small blank already shaped for its task. The bottle did not need a permanent mechanical clasp. Production lines could move liquid, glass, and closures through separate operations that met only for a second. The cap also made evidence. A crown is visibly deformed when removed and cannot be restored neatly by hand. That made it useful not just as a seal but as an indication that the bottle had been opened. Painter's design was not modern tamper-evident packaging in every regulatory sense, but its one-use character changed what buyers could infer from an intact closure. A new inconvenience followed immediately. A cap locked firmly enough to survive transport also resisted fingers. Painter answered with another small object. His 1894 patent 514,200 describes a handled opener with a lip that catches beneath the cap and a bearing point that uses leverage against its top. The closure and the opener formed a pair. One standardized the act of sealing, the other standardized the act of release. The opener is a beautiful example of design creating its own tool. Before the crown, a household might use a corkscrew or manipulate a reusable stopper. After the crown, the familiar levering motion became part of serving a drink. Bars, kitchens, picnic baskets, and shop counters acquired a device whose shape made sense only because millions of bottlenecks now ended in the same crimped rim. Painter organized his business around that repeated demand. The Smithsonian's National Museum of American History calls him the inventor of the disposable bottle cap and notes that he made his fortune from it. The money did not come from a single dramatic machine sold once. It came from a tiny component consumed each time a bottle was opened. That model reached beyond beverages. King Camp Gillette worked for Painter. According to the Smithsonian, Painter advised him to invent another disposable item that would create a steady stream of returning customers. Gillette applied the lesson to safety razor blades. The connection is startling because the bottle cap and razor blade do not look related. Their shared invention was a business rhythm. durable holder, replaceable piece, repeated purchase. The pattern has since become so common that it is difficult to see. Printer cartridges, filters, medical test strips, coffee capsules, replacement blades, and countless packaging components all separate a longer-lived system from a consumed unit. Some uses are convenient, others create waste or lock customers into proprietary supplies. The crown closure sits near the beginning of that debate. Disposability solved genuine sanitary and logistical problems. A fresh cap did not need to return through the distribution network. It could be manufactured under controlled conditions and applied quickly. Yet multiplied across billions of bottles, a few grams of material become a mountain. Successful small objects alter both production and rubbish. Their scale hides in repetition. The crown also traveled well. A compact closure helped make sealed carbonated drinks practical across longer routes and larger markets. Bottlers could promise that the liquid arriving at a distant shop remained contained behind a mechanically applied seal. Branding happened on labels and caps, but the deeper commercial fact was confidence. The same quick opening gesture released a product closed by the same industrial grammar. Modern versions have changed their linings and materials. The original patents discuss compressible packing discs, historically associated with cork. Later closures adopted new compounds and plastics. The principle remained recognizable: a formed metal shell, a sealing liner, and a standardized glass finish. A design can survive the replacement of nearly every material detail when its interface is right. There is a quiet choreography in opening one. The opener's lip slides under a flute. The handle rotates around a point on the cap. A small section lifts, then the crimp releases around the circumference. Pressure equalizes with a brief sound. The closure that tolerated filling, handling, cooling, warming, and transport becomes useless in less than a second. Its success ends in deliberate failure. That planned ending distinguishes the crown from a screw cap meant to close again. Painter designed a component to be destroyed at the exact moment it completed its duty. Engineers often seek durability, but duration is not always the goal. Sometimes the best part is the one that remains reliable until a chosen force makes it surrender. The dinner table connection begins with this controlled surrender. The common bottle opener exists because painter's cap made ordinary fingers insufficient. The disposable razor blade exists, in part, because painter told Gillette to seek another cheap item people would buy repeatedly. One corrugated disc changed factory speed, bottle design, serving rituals, waste streams, and the logic of consumer products. So the next crown cap is more than a lid. It is a tiny negotiated interface. Its folds grip a shoulder standardized into glass. Its liner absorbs imperfections. Its low price permits one use. Its resistance requires leverage. And its commercial success taught another inventor to place the valuable handle in one hand and the replaceable edge in the other. A bottle closed in 1892 quietly helped shape the razor waiting beside millions of sinks. The cap also changed where precision had to live. A handmade cork could be trimmed to the individual neck in front of the worker. A crown closure moved that adjustment upstream. Glassworks had to form a consistent mouth. Closure makers had to control the metal shell and lining. Capping machines had to apply a repeatable force. The bottler gained speed only because several industries accepted tighter responsibilities before the bottle reached the filling line. Painter's patents reveal how many small questions hid inside the apparently simple disc. Should the flange grip an external shoulder or another feature? How should the soft packing touch the lip? Could a closure remain cheap after being stamped, lined, transported, and fed through machinery? Would removal tear the cap, bend it, or merely loosen it? An invention becomes industrial when these questions receive answers that survive repetition. Repetition created a supply chain. Sheets of metal became blanks, blanks became formed caps, liners entered the shells, and boxes of closures traveled to bottlers that did not need to know the cap maker personally. Tooling converted the geometry into quantity. Gauges and bottle specifications converted quantity into compatibility. A single closure is almost weightless. A closure system includes furnaces, presses, glass molds, conveyors, warehouses, and millions of identical expectations. The sound of opening also became cultural shorthand. The short release of pressure tells a listener that the seal held until this moment. That sound now appears in kitchens, stadiums, workshops, and celebrations, yet it is the audible result of an engineering compromise. The bottle contains pressure, the liner prevents leakage, the metal resists lifting, and the opener concentrates enough leverage at one flute to break the agreement cleanly. There were competing closures, and the crown did not erase every cork or mechanical stopper. Wine, medicines, preserved foods, and reusable bottles retained other systems where ritual, resealing, material compatibility, or product tradition mattered. The crown succeeded spectacularly in the territory where speed, pressure, low cost, and one-time opening aligned. Good standards do not conquer every problem. They dominate the problems whose requirements match them. Its visual simplicity helped. Corrugation strengthened and shaped the skirt while giving the opener repeated places to catch. The shallow profile used little metal. A printed top could carry identification without changing the bottle. A bottler could adopt new graphics while preserving the same mechanical interface. Commerce changed on the visible surface, machinery depended on the invisible dimensions beneath it. The closure also separated the bottle's life from the stopper's life. Glass bottles could be collected, washed, and refilled while each filling received a fresh cap. Reuse and disposability therefore lived together rather than replacing one another outright. The durable container traveled through many cycles, the cheap seal performed one precise cycle. Modern packaging still makes this trade: which component should return, which should be renewed, and where should sanitation or convenience outweigh material cost. Painter's advice to Gillette becomes more interesting in that light. It was not merely a cynical recommendation to sell waste. A replaceable unit can deliver a fresh working surface while the larger tool remains useful. The ethical and environmental outcome depends on materials, recycling, repair, competition, and whether the replacement is genuinely beneficial or merely proprietary. The crown cap introduced a durable commercial idea, not a verdict on every later use of it. Look closely at a removed cap and the entire sequence is preserved in deformation. The folds that once gripped the bottle shoulder have opened. The liner carries the faint circular impression of the glass lip. A small bend marks where the opener applied force. The object is an archaeological record of manufacture, sealing, transport, and release, all compressed into something usually brushed from a table. That is why this tiny closure belongs in the history of systems, not only bottles. It coordinated materials made in different factories, rewarded standard bottle finishes, invited high-speed machinery, required a companion tool, and demonstrated the economics of a replaceable component. The liquid may have been the product people wanted, but the crown made the promise portable. This bottle was sealed somewhere else, survived the journey, and waited intact for one deliberate movement of the hand.